Okay, maybe I'll start now. Okay.
嗯
大家好，欢迎来到今天的那个 OpenTutorials。今天呢，我们很有幸邀请到了浙江理工大学的闵胜炫教授啊，他是韩国裔加拿大籍，现在在浙江理工大学工作的那个特聘副教授。呃，Sam 他的主要研究方向呢是目前做的比较多的是视觉，比如说那个弱视，然后同时呢，他对可视化非常感兴趣啊，自己开发了很多个包，目前还有另外一个包正在这个筹划过程中，呃，就希望能够帮助我们在心理学的研究中呈现出更漂亮的图像。那今天呢，很有幸有他来向我们更详细的介绍一下他的 smplot2 啊，这个不知道大家有没有注意到，SM 其实就是Sam 敏啊，就是他的这个名字，然后形成的这个包的名字啊，这个包一会儿他会Sam maybe you can share the link in the chat。
，All right，
Yeah. 他会他制作了这么样一个网页，也是用应该是 QMD 文件做的。大家感兴趣的话，也可以同时打开这个网页，然后来跟着他一起来学习这些内容。在这个过程中，大家如果有问题的话，可以用中文或者英文直接发在这个chat 里面，或者直接那个举手，都是可以的啊。希望大家今天对于这个可视化的方面有一些收获，也希望能够更多听到大家的反馈啊，与这个Sam 教授来进行一些交流。那我们接下来就有请那个 Sam 教授来给我们介绍他的这个 SM Plot 2的报告。OK, Sam, now the floor is yours.
well, thank you, Hayang, for the introduction. So, thanks, guys, for coming to the tutorial. So, this tutorial is about my package called smplot2. So, it's designed to create elegant figures for scientific publications. So, this tutorial is perfect for you if you guys want to improve your skills in data visualization and if you're performing scientific research. So this tutorial will walk through the basics step by step. So first of all, why did I make the package smplot2? So what does it do? It helps you guys to create figures using ggplot2 and R. ggplot2 is the most widely used data visualization library in the world. However, producing publication quality figures in ggplot2 is quite challenging and it requires a lot of coding, actually, more than you'd expect. So in 2021, after I got my PhD, as like a fun side project during the summer holiday, I decided to create shortcut functions for plotting figures and then put them into a package. So that's how smplot was developed. And in the middle of 2022, I realized that I had to rewrite the whole package because I made some mistakes. So I rewrote the whole thing and it changed a lot of things. And so to make it clear for users, I decided to rename the package into smplot2 from smplot. So so first of all, smplot2 was introduced officially on CRAN, which is the repository for peer-reviewed packages from April 2024. So it's gotten about more than 19,000 downloads so far. And the documentation website for the package is sv95.com/dataviz. And it has more than 300 reproducible examples. So first of all, if you guys are running computer or studio, you could download the package using this code, install packages, quotation, smplot2. Okay. So there are some citable sources of the package that I've written in the last 5 years. So if you guys do use the package for your research or publications, it'd be great if you guys could cite one of these two papers. So for this tutorial, we will mainly talk about what's discussed in this paper about creating elegant figures. But if you're interested in what is in this paper instead, then you can feel free to take a look at the paper or visit the documentation website, which has more information about the package. So this tutorial has reproducible examples. That means that if you copy and paste the code right away, the examples should work without any problems. So to make sure that the examples work as intended, you need to load these two packages, tidyverse and smplot2. So tidyverse is basically a suite or a collection of our packages for performing data science, and it includes important packages like ggplot2, dplyr, readr, all these packages that you might have heard of. And smplot2 is the package that we are going to talk about to plot figures. Okay, so let me just change the screen for a second. Then let me just change the screen. Then hopefully you guys can see the whole screen. So you should go to RStudio and download package. So how do you do that? Type install packages, smplot2. Can you confirm if you can see my screen? It's good. Okay. Anyways, so I'll
Yes, yeah,
continue.
yeah, we can see it.
Okay, great. So we need to run this code. All right. And if you have not installed the other package, tidyverse, you should also install it like this so you can run it by highlighting it and clicking run. Okay. Then after you wait for a while, you will have downloaded the package. The next, you need to upload or load these packages into memory. Okay. So how do you load them? You type library bracket and package name without quotation marks. Okay. So after you load these packages, now we can produce the examples that we will draw in this tutorial. So before I talk about smplot2's basics functionalities, I would like to talk about some fundamentals of ggplot2. So ggplot2, GG means grammar graphics. So what does that mean? It basically means that you're starting from a blank canvas, an empty graphical space. And then the idea is that on top of the graphical space, you add elements using plus sign, okay, line by line. So think of it like as like a painting. You start with an empty canvas, and then you add elements one by one. So let me just demonstrate what this means. So, so let's say you load these two packages, okay? Then you start by typing ggplot and bracket. You are going to have an empty graphical space, okay? So the first line in ggplot is not about drawing, but it's about defining this plotting space, okay? So if you load tidyverse, the data called mpg, miles per gallon, will be loaded automatically. And if you want to plot this data, mpg, you need to define that you will plot this data within ggplot function. Okay, so using the argument data, you need to specify the data variable that you want to plot, which is mpg. Then you want to define the x and y axes. The x-axis will be defined as displ, which is one of the columns in this NPG data frame. And the y-axis, we define it as HWY column, which is here. Okay. So after you define the plotting space, what do you get? Instead of an empty canvas that we initially saw, you see a defined plotting space, but you do not see any point. So how do we add points? You use the plot operator, and then you add a line that draws point, which is geom_point. So now automatically, layer by layer, we've defined the plotting space, and then we added point line by line. And this interface of where you add graphical elements line by line is known as the grammar graphics. Okay? And this is what ggplot2 is all about. Okay? So that's ggplot2. And if you guys are interested in more details, you can read this on your own. Okay? So the important thing is this plus operator. Okay? You can add graphical elements line by line. So now let me talk about basic plotting themes, background themes of smplot2. So a lot of people find that the background theme of the ggplot2 is not quite suitable for scientific publications. Why? There's a lot of noise. The gray background captures the reader's attention from the data. There's also a lot of grid lines, major and minor grid lines. So, as well as the fact that the font size is inconsistent, the font size of the axis text or tick labels is smaller than the axis titles, for example. So it's really good to standardize and scale the font sizes to increase the readability of figures, especially for scientific publications. So how can we apply the background provided by smplot2? So you add a plus sign from the given plot, and you add a function called smhgrid. What does this do? It adds this horizontal grid theme onto the plot. Okay, so let me show you the plotting output. This is what it looks like. Okay, the font size has been scaled and maximize readability. But now notice that the legend is missing. We do not know what each color represents. So how can we add the legend? In ggplot2, if you want to add a legend, you have to use theme, legend, position, okay? And it's really complicated. So what I've done here is you can actually use the legend input and set it as true. Then you can get legends just by specifying the legend argument using smhgrid. So smhgrid draws major horizontal grids. And there's also other functions for background, classic, and SMHV grid. So V grid is the vertical grid, and the HV grid is the horizontal and the vertical grid. So one extra background that I like to talk about is SM Classic. So what's that? This literally means classic plot. This is what you get. No border. Okay. So these have been optimized size-wise for scientific journal formats. So they're really readable. So as I said before, you can add legends just by specifying the legend argument to true. Okay. So that's it for the backgrounds, the smplot2 themes. So now we will talk about scatterplot. Scatterplot is basically the plot that we just drew before. There's a bunch of points all together. Okay. So we can also change the border. Okay. So scatterplot, right? So we can actually try to use some HV grid and remove the border of the plot. Then you would get something like this, no border. Okay. So this is what it looks like. So just by adding SM background functions, it gives you a white background, clean grid lines. Okay. In this example, by setting borders to false, we remove the border around the plot, and there's better font sizing. Okay. So that's it for the background themes, I think. Now we are going to move to correlation, adding correlation statistics. So I, so when I built a package like 4 years ago, I just added this function for fun, but now it is one of the most widely used functions of the whole package. So let me talk about how you can add correlation statistics using a smplot2. So if you guys are following this example, you guys can copy and paste the code just by clicking here and go out to RStudio and then run the code. So this is a default ggplot2 correlation figure, where the x-axis is DRET and y-axis is MPG, and this data is coming from this data frame called MT cars. Okay, so data frame about cars, different models, functionalities. And this data is automatically loaded if you've loaded the tidyverse package. So this is a classic shape. This is a classic correlation like esque figure where you see a positive relationship. So in this default figure, we've customized the aesthetics of points such that the shape is circle with border. So that's 21. And you have the fill argument specified as green color, which is the filling color of the point. We've also specified the border color of the point as white using color argument. And finally, we have specified the size of the points by setting the size argument to 3, all within geopoint function. So that is the classic ggplot2 figure with its gray background and a major and minor grid lines. So now, on top of this figure, we can add correlation statistics using the function called smstat4. So if you do this, it automatically adds the statistical result as well as the regression line. Okay, so let's try that. If you so this is a basic plot. And if you use the plus operator, go to the next line and type sm.core, then you get this plot with this regression line and the statistics printed automatically. Okay. So, but the blue is quite ugly, and we will later customize the color of the regression line. Okay. So what does sm.core do automatically? It adds a correlation line. It displays R squared or R as well as p-value. And it uses Pearson correlation by default, but other methods are also available, like experiment. If you guys are analyzing non-normal distributed data. So now we will customize correlation display by using more arguments inside within sm.core. So in this example, we've drawn a correlation plot with a green dashed line. And notice that instead of R, we displayed R squared. So notice that the value is different between this figure, 0.68 R versus 0.42 R squared. So how did we do this? We've specified that R squared be printed on the plot by specifying R2 argument as true. Okay, by default it's false, printing R, but by setting it true, we now have R squared on the figure. And here we've used correlation method using the Spearman test, not Pearson. Okay, so this is really easy to use, especially for those who have just learned R or have used R. Okay, it's really easy to customize aesthetics as well as showing the statistics. Okay, so you can also use something called fit params and then put all the aesthetics inside this list function. That also works the same. Okay. So I think one highlight of this function is that you can also do this in different situations. So for example, a really so in ggplot2, you can actually split one plot into different plots based on a variable using the function called facet wrap. So what is it? Let me just demonstrate. So this is the base plot. Okay. You have a lot of points. But let's say that we want to show separate plots based on the variable called CYL. Okay. There are three levels of CYL in the data frame and T-cars, 6, 4, and 8. And I like to, in this case, to draw a separate facet plot based on the level of CYL. So how do I do that? So you can use facet wrap, tilde, and write CYL. And what do you get? You get three different plots. Okay. So what does this mean? This plot is from the rows in the data frame where the CYL is 4. Okay. This one is from the data frame where the CYL column value is 6. So like Mazda RX4, Mazda RX4 WAG belongs here. And for here, we would see Mercedes 450 SL, okay, Mercedes 450 SLC. These are all in this plot. So we've divided the plot into three facets, okay? So I want to show correlation statistics and the regression line for each facet. How do I do that? You do the same thing as what you did before by adding smplot2 function. So if you just write this function, it automatically draws the correlation line and statistics to each facet, to each level of CYL. So this is the reason why SM has been one of the more popular functions of the package because it is very easy to use and report statistics. So you can customize the aesthetics of the line to each facet by using the same method as before, by using color input. So here you specify the color argument as green color. So we use hex code, which are six letter string or six character string, and the line type has been specified as dashed. So let me just try this. Okay. So this is what it looks like. So you can change the color. For example, so SMplot has like different colors as well. So you can like, so now we have a blue line with green points. So if you want to make them look the same, you can have a blue plot. Okay. So yeah, so that's it for correlation. And now we are going to move to bar plot. So in this example and now onwards, we're going to use our own data set, our own randomly generated data set. So we will generate data set where there are 16 individuals with three measurements each. So how do we do that? So you just copy and paste this code by clicking here and go to our studio and just run the code. Okay, just run the code. Then what is DF? You have 16 individuals, fake data with value and time. So time has three different levels, day 1, day 2, and day 3. Okay. And the mean value of the data for each day is different. Mean is around 0 for day 1, mean is around 5 for day 2, and the average value for data is around 10 for day 3. So let's just confirm that the average is correct. So let me just check it right now. So you guys don't have to follow the code. So check. So here is the average. So I've just calculated the average of the data per day, per time. So the average for day one is around 0.25, and day two is around 5.5, and day three is 9.9. So that's very similar to what we've tried to replicate and to achieve. So after confirming that our data randomly generated data set has the average values that we want, we can proceed plotting a bar plot. So now let me show you a traditional bar plot with ggplot2. So drawing a bar plot in ggplot2 is not so straightforward because you have to use a step summary function here in this example, and it's not quite straightforward. So there's a lot of inputs that you have to specify. Okay. It's a lot of lines of code. It's not easy to plot, although bar plot is very widely used in different fields. So in this bar graph, there are three colors, red, green, blue, which are the default colors of ggplot2. And on top of the bar, you have individual points. Okay. Because the bar plot does not show any distribution or any other information, it is generally considered a good practice to show individual data points. Okay. However, this requires a lot of lines of code and steps. There are several steps here that we are doing in this example. We're calculating the means for bars for each level, for each day. Then we're putting the individual data points. We're then adjusting the transparency and the position of the points to maximize the clarity of the figure. And we've also removed the legend, okay, using this code. So that's a lot of lines of code for just one bar graph, okay? So what happens if you use smbar? It becomes much more simple. So, so if you write, so this is the first line of ggplot code where you're defining the plotting space. And if you type smbar, then it's gonna automatically display the bar, the points, and the error bar. The error bar here is standard error, and you can actually change the error bar type using error bar type argument to other types like standard deviation or 95 confidence interval. Okay, so it's very easy to do, and the default is standard error SE. Okay. So notice there's only two lines of code where the first line is just defining the plotting space. And we can actually now define a color. So smPalette is a function that returns a certain number of colors. So I've used the function scale color manual, which is a function from ggplot2 to define the color at each level of time. Okay. So notice that smbar function does all the heavy lifting in one line of code by calculating the means for bars, adding individual points with some jitter, and it uses nice default aesthetics to maximize the clarity of the figure. So these three colors are from the smplot2 color palette. So smplot2 has one color theme, and that is the color that I use all the time for anything and everything, all into this package. So if you use the function smColor and you write these names, then you are going to get something called the hex code. Okay, so let me try smColor. Then you get this hex code. Okay, then this is this color. So notice that this blue slightly looks different than this blue, that which is the default for R. So let me try other ones. Red. Red is so the colors from smplot have high contrast, and so that makes it really clear to represent different levels, different variables, or different types of data sets. Okay. But what happens if you're lazy? Like, for example, you want these three colors, blue, crimson, and green. You want these three colors, but how do you get these three colors without writing the name of each color? You just write no, three color, three, with the function smPalette. Then you just get these three colors. So if you write smPalette2, you're gonna get these two colors. And if you write smPalette 6 to 20, then you are gonna get these colors in order. Okay? It's very convenient. So now let's try to use the function smColor on bar plot. So copy and paste the code. So this is a bar plot default using the colors from ggplot2. Now we want to customize the color by using smColor function. So so for this exercise, you can just pick any three colors on your own and create your bar graph. So in this example, I use the wine color, sky blue, and light brown. Okay. And then this is what it looks like. Okay. So let me just try that here. So it looks quite elegant, and I think the colors are very different from each other, so you can actually tell which level is which very clearly, which is a goal in scientific publication. So if you want to name your colors in any order, use SM color. But if you just want to get these colors in order, then use SM palette and provide the number of colors that you want. Okay. So this is a customizing bar plot in a more advanced way. So I'm going to tell you what I did here to make it look more elegant. So the first line here defines the plotting space using the randomly generated data, df, and x-axis is defined as time, day 1, day 2, and day 3, and the value is the y-axis. And I set so that each level of time has a different filling color. Okay. And within the SM bar function, I set it so that the bar's width is about 0.5 and that the bar color has transparency to 50% alpha. Okay, so the higher the alpha, the lighter it's going to be. So here is 0.5, so it's really light compared to this one. And there's point params where you can provide different arguments to specify the aesthetics of points. So here the boring color of point has been set to white, and the shape is circle with border, so that's 21. And stroke input is argument in ggplot2 that defines the border width of the point. And alpha 1 means no transparency, so these points are dark. Okay. So I've set the y-axis scale from -5 to 15 by using the function called scale y continuous. And I've set so that there are three colors of the points, okay, in the bar graph using wine, sky blue, and light brown colors as defined in the smplot2's color theme. Okay, so you can just copy and paste this code and try to change the color to your own choices and see what happens. Okay, so that's it for the bar plot. So to summarize, the bar plot function in smplot2 plots the bar in the same color, but it plots the points in different colors. And it also It reduces error bar in different formats based on how you specify the function. Okay. So now we're going to briefly talk about box plot because a lot of people also use box plot. So box plot is very easy to draw in ggplot2. So how do we do that? You just use the function box plot. So let's try that. Okay. In RStudio, box plot. So you get this figure, classic box plot generated with ggplot2's box plot function. So here you see legend as well, which is not required because we already know that red represents day one, while blue represents day three. And so the common practice in scientific research is that when you're drawing a box plot, it is also very normal to plot individual points. And that could be done here by using the function called geom_jitter. Okay, so let's do that. So what happens if you add geom_jitter? You have this jittered spread points around the box plot. So, or you can just use box plot and it just plots the box plot in a similar style that you saw from the bar graph. So the box, not the bar in this case, has the same color at all levels, but the points have different colors based on each level of the x-axis. So if this is a style that you want, which is very simple and minimalistic, then you can use the function smboxplot. Okay. So now I'm going to briefly talk about slope chart. So what is a slope chart? It's very useful to show changes between two time points or more for each subject. So if for this example, you just copy and paste this code to generate randomly generated data. Okay. So this is what it looks like. So it has 20 subjects with some volume, and there are two time points before and after. So this slope chart format is very useful for clinical studies or where you want to study the effect of intervention. So there's before and after. Okay. So this is what it looks like, slope chart. From what I know, there is no default function that draws slope chart in ggplot2, but there might be now. I'm not sure, but I don't think there is. So that's why I made this function called smslope, where you can specify how you could group each observation and color it as well to draw the slope chart. So slope chart is very useful to track changes at different levels. Okay. So notice that I've used two colors from the smplot's color theme, blue and orange, because blue and orange come really well together. They're really good pairs. And I specify that group should be subject. What does that mean? Each line is paired in one group because each pair represents subject. Okay, so I've grouped these points using the subject variable. So this is subject one, subject one. So they're all connected. Okay. So it is very useful if you want to show individual trajectories or changes. Okay. So you can actually change labels instead of just writing Z and Y, you can specify the labels by using the labels argument and brackets before and after. Then you get this nice, elegant slope chart. So personally, I use slope chart a lot because I've done a lot of studies that measure the effect of specific interventions in visual treatment. So, and I found that this is very useful. But sometimes it's also useful to show the average of these individual data points. Okay. So you can actually show average by setting show mean to true. Okay. Then we will show you the average. Okay. Then you can also change the color to make the average plot more clear in the midst of this cloud of individual points. So how do we do that? we can emphasize this average plot by making it darker, and we can de-emphasize the individual points by making them lighter. So for example, this is what I did. If you just copy and paste these codes, you will get this slope chart where there is a dark, strong average plot. And at the back, you have these individual points with more transparency. Okay. So you can customize in a very fine detail using the argument system within smslope function. Okay. But this is a lot of lines of code. So I later created another function where you can just create this exact same slope chart showing mean in a more concise way. So I've created a simplified function called smSlopeMean. It's very useful if you just want to show average. And you can, so how does it work? You define the labels by using the labels argument. You specify the group. So that's the connecting line. A subject. So this is called, and the next argument is called back alpha. That's basically the transparency level of the point and lines at the back. Okay. So the main color is the average plot. Main shape is the shape of the average plot. You can also show error bar or error line by setting show error true. You can specify the error bar type in either SD, SE, or CI. So smSlopeMean is a convenient function if you guys are interested in drawing a slope chart with mean. Okay. So let me just drink some water. Okay. Next, we're going to talk about rain cloud plot. This rain cloud plot has been popular since 2019. So it's relatively a new plot function. So it's basically a combination of violin plot, box plot, and individual points. So if you guys want to produce the figures down below, then you should copy and paste this code that randomly generates data. So you can just copy and paste the code, right? Clicking at the right corner, and then you can just run it. So this is what it looks like, this randomly generated data. You have 20 subjects, 20 subjects. And there are two groups, group one and group two. So there is no default ggplot2 function for drawing a rain plot. So I can't show you what default looks like, but if you use SM rain cloud, you can just draw this rain cloud, box plot individual points, violin plot all together using just two lines of code. Okay. So if you want to specify the colors, you have to use the argument called scale, fill, manual. Okay. Then you get something like this. So if you want to use blue and orange, for example, then use SM colors and write blue and orange. And you will get the same example as shown here. Okay. So I personally really like to use blue and orange because they're high contrast, they're very different, they're complementary colors. So rain cloud plot basically show density plot, the violin plot, which is basically the cloud. And there's a box plot, and there's points. So let me just show you guys why is this called a rain cloud plot? It doesn't look like rain cloud at all. So if you change the orientation, okay, if you change the orientation of the plot, it will look like a rain cloud. And you can change the orientation of the plot by using the argument called vertical. So the default is vertically positioned plot. But if you set the vertical argument as false, then you are going to get this rain cloud shape because now it's not a horizontal function where the rain droplets are basically the points, individual points below the cloud, where the cloud is the violin density plot. Okay, so you can add different color schemes. There's red, and dark green. So we'll try it out here. So it looks really nice. And fun thing is you can actually adjust the level of separation between different visual elements. So let's try that. So for example, I want to separate all elements like to the extreme as possible. And so how do you do that? You adjust the level, the separation level by specifying the argument called set level. Set level has basically different levels, so 0 to 4 where 4 is maximally spaced out, while 0 is all crowded together. So if it's set to 0, they're all crowded, superimposed on top of each other. Okay. So you can have some fun customizing it. So set level controls spacing between elements, where 0 is minimal separation, and higher numbers mean more separation. Okay. So if you set it set level 4, you are going to get separated on rainbow plot. So how do we flip this rainbow plot? How do we flip it? It's now facing to the right, right? But how can we flip it? Use something called which side. So which side argument. If you set it as L, it's going to flip it. Okay. So you can have a lot of fun to see which format or orientation matches or maximizes the clarity of your data. Okay. So which side controls where points appear? Okay. Not where the density points appear. So this is left and this is right. Okay. So this is right. So last plot that we are going to talk about is called the forest plot. Forest plots are very useful for comparing multiple groups or conditions or levels, especially meta-analysis. So to plot forest plot, you need to copy and paste this randomly generated data set. So you just copy and paste and run it in our studio. Then you are going to get something like this, where there are 20 subjects at 4 different levels: day 1, day 2, day 3, and day 4. Okay. So this is what it looks like with just 2 lines of code. You can generate this forest plot. So by default, it has is a vertical line at the level of 0 x-axis. So this is what we call a reference line, reference to 0. Okay. So forest plot show individual points for each observation distribution, and so it also shows density distribution by the transparency. So if it's darker, there's more points. Okay. And it's very useful if you want to compare different groups. So you can customize the colors by using scale color manual function in ggplot2, using colors provided by smplot2. And here I sort of extracted 4 colors from smpalette function. And this is what you get using the 4 colors. Okay. So it's also very useful to add jitter to the point. Okay. So what's jitter mean? Jitter means that the points are spread like this, like rain droplets. So you can control the amount of jitter that you see in your plot by adjusting the argument called point jitter width. So here it equals to 0.12. And there's also the function set level. It can control the separation level between different visual elements, like in rain cloud, but in forest plot using the set level argument. Okay. So point jitter width controls the horizontal or the spread of the points, and set level controls the vertical the separation between different visual elements. So summary is in this tutorial, we've covered basic themes for clean plot styling, We've also talked about correlation plots, displaying correlation statistics, and regression line. We've also talked about different types of plots, like bar plot, slope chart, rain cloud plots, and forest plots. So a smplot is very useful if you have just begun learning R, okay? But for experts, it might be less useful because they'd want to customize more and more. So it's a great introductory R package if you guys want to spend more time on data visualization. Okay. And if you want to see more examples, you can check the documentation website on here or smin95.com/dataviz. So I guess that's it. Thank you for listening to the tutorial.
Okay, thanks. We are happy with what we got today. We will stop here. And thanks for everyone who coming, and hopefully you will have a good night. Bye bye.
Bye guys. Thanks for hosting me, Hayam. And
You're
thanks for
welcome.
everyone for listening.